In the previous video, we find out the general solution of the regular falsy method. We find out the general approximate roots of the equation. Now in this video, we are going to discuss an example related to this method. Consider the function f of x, x cubed minus 4x plus 1. I will consider any 2 points on which the function is showing the different behavior. Use these points in the function and check the behavior. I put 0 in the function, I got a positive value, and when I put 1 in the function, I got negative value. So this means that my root lies between 0 and 1. Since f of 0 and f of 1 are of opposite signs, the root lies between 0 and 1. So a equals to 0 and b equals to 1. So the first approximate root will be a f of b minus b f of a over f of b minus f of a. Since a is equals to 0, so I will put in place of a 0. F of b, the value of f of b is calculated above. This is b and this is a. So these values are I have calculated already. So put these values in this formula and you will get x1 equals to 0.333. Now check the behavior of this root. Put this root in the function. I got negative value. Since the previous roots, f of a was positive, f of x1 is now negative, and f of b is negative. We have considered this root now, f of x1. So move on around these roots and check the behavior, whether we have same behavior on one side or the opposite behavior. When we move toward b, we have the same behavior, so we will not take this value. Move on its left hand side, we see the function's behavior is changing from negative to positive. So this means our root lies between a and x1. So our second approximate value will be calculated using a and x1. So the formula for second approximate value will be a f of x1 minus x1 f of a over f of x1 minus f of a. Use the values that are calculated earlier in this formula and get the value for x2, that is 0.2571. Now use this value in the function and observe the behavior again. Now we have f of a, f of x2, f of x1, f of b. Observe the behaviors. Right now we are here, f of x2. Function is showing the opposite behavior here, positive and negative. So this means our root lies between a and x2. So our third approximate value will be calculated using a and x2. A f of x2 minus x2 f of a over f of x2 minus f of a. I got 0.2541. I will take the approximate values, calculate the approximate values until my root is repeated up to 3 decimal places that is mentioned in the question. So I will continue this process until I will repeat my root. I will get a repeated root up to 3 decimal places. Now put this value for this third root in the function and observe the behavior again. Right now we are here on f of x3. Observe the behavior. This is positive, so we move towards the negative root. So my root lies between x3 and x2. So my fourth root is calculated using this formula and its value will be 0.2541. Now look at the previous root. That was x3 equals to 0.2541. And again I got 0.2541. It means my root is 0.2541 since it is repeated. So in this way we will calculate the roots using the regular falsy method. For the next method, just subscribe the channel so you can get timely the updates of the new videos. Thank you.